In this video from ITFreeTraining, I will look at installing a standalone root certificate authority, or root CA, on Windows Server 2012. The root CA is the top of the trust model for your certificate infrastructure. This video will look at how to install it and also how to protect the root CA. To recap what was covered in the previous video, a public key infrastructure hierarchy contains a root CA. This root CA contains the private key for the whole certificate infrastructure. This needs to be protected, as if it were stolen, the security for the public key infrastructure hierarchy would be lost. This would be the same effect as having a master key for every door in a building. If this key were lost, every lock in every door would need to be changed to ensure security. The same with public key infrastructure. A new root CA would need to be created and every certificate on the network reissued. In order to help protect the root CA, subordinate CAs are created which issue certificates directly to the clients. Once these subordinate CAs have their certificates, the root CA is not needed. For this reason, in this demonstration, I will use a server that does not have a network adapter connected to the network. It is completely isolated from the network and thus protected. In a later video, I will install the subordinate CAs. I will use a floppy disk to transfer the certificates from the root CA to the subordinate CA rather than using the network. This is a common practice for root CAs to have certificates transferred using removable media like USB flash drives. Often, a root CA will be installed on a virtual machine, and the virtual machine, when no longer required, placed on a physical media and locked in a safe place to keep it secure. In this case, since the root CA is on a server with no network card, the only way the key could be stolen is if someone was able to physically get to the server. Without further ado, I will change to my Windows Server 2012 computer to look at how to set up a root CA. First of all, I will open Windows Explorer and open the properties for the network. This will open Network and Sharing Center. You can see here that the server is not connected to any networks. If I select the option on the left, Change Adapter Settings, notice that the only network adapter listed has been unplugged. Since this server will contain the root CA, it has been disconnected from the network and will not be reconnected. When this server is used to issue certificates, they will be transferred to the other server using a floppy disk. However, you could also use a USB removable device if you wanted to. I will now exit out of here and go to Windows Explorer and open the Windows directory. In the Windows directory, I have placed a file called capolicy.inf. This file is not created by default, but is required by Active Directory Certificate Services in order to configure it unless you are happy with the defaults. When I open the file, notice that there are a lot of different options in the file. For a full list of options, see the references part of this video. There is also a link to download a copy of this file. The first part of the file is the version part. This must be in the file and is the only part required for the file to be valid. It is just a simple matter to copy and paste these two lines and place them at the top of the file. The next section is Policy Statement Extension. This contains one line called Policies. This line indicates the policies that apply to this CA, separated by commas. In this case, there is only one policy called Internal Policy. Policies do not affect the operation of the CA or the clients that use the certificates. Policies are like the license agreement that is presented to the user when they install software. The policy defines the legal requirements the user needs to follow when using certificates issued from the CA. It is up to the person using the certificate to read the policy and make sure that they are following the policy. The first line is OID, or Object Identifier. This uniquely identifies the policy. If you were using certificates with different organizations, but they were using the same application, you may want to define an OID so this policy can be identified as the certificate policy for that application. In this case, this OID is an OID that Microsoft registered. If you want to register your own OID, see the reference part of this video on the steps required to do this. The next line down is the text for the policy. This will be copied and pasted into the certificate. After I install the CA, I will show you how to read the policy inside a certificate that it has issued. The line under this is the URL that the user can open to read policy information for this certificate. In this case, I have used a local DNS address. However, if you were issuing certificates to external companies, you would want to use a DNS that was resolvable on the Internet. The last section is options of the CA. This part determines the settings that will be used when certificates are created. The first option, renewal key length, determines the key size that is used when a certificate needs to be renewed. In this case, this key is used when a subordinate CA needs to renew its certificate. You can choose a different value than the value used to create the certificate. For example, you could use a lower value or higher value. The important point to remember is the values you choose need to be compatible with the applications and software that will use the certificates. For example, you could not choose a 4096-bit key for the root certificate and later find out that the devices on your network only support 2048-bit encryption and attempt to use a 2048-bit key to renew the certificate. This will not work, as the renewal key is only used to obtain the new certificate, which will still have a digital signature based on the 4096-bit root certificate. The next setting, renewal validity period, is combined with the next setting. In this case, it is set to years. It could, however, be set to months, weeks, days, or even hours. The setting used here affects the next setting, renewal validity period units. In this case, this setting is set to 20. When combined with the last setting, this means the renewal period has been set to 20 years. We will see in a moment when Active Directory Certificate Services is installed, it will request how long the certificate is valid. This will be used in the initial creation of the root CA certificate. The value shown here is only when renewing the root CA certificate. The next setting is alternate signature algorithm. This uses a newer algorithm to create the digital signature used in the certificates. If this is enabled, this essentially means this certificate requires Windows Vista or Windows Server 2008 operating systems or above. Older operating systems do not support this option. If you have Windows XP or Windows Server 2003 clients, this includes servers used as certificate authorities. Make sure this setting is not enabled, or certificates from this certificate hierarchy will not work with those clients. The next option is CRL delta period, which is set for days. It does not matter in this case what the value is set to, as the next value, CRL delta period units, is set to 0. CRL stands for Certificate Revocation List. Delta in this case refers to differences. So this setting is essentially saying how often to send differences in the certificate revocation list. The revocation list is certificates that have been revoked or canceled. In this case, the value has been set to 0, which means never send any changes to the certificate revocation list. Why would you set this value to 0? In this case, this is a root certificate server, which is never connected to the network. For this reason, it is impractical to have it send changes to the revocation list, since it will never be able to connect to other CAs using the network. In this case of offline root CAs, you always want to set this value to 0. That's the end of the config file for this server. It's important before you install your root CA that you have a look at the options that are available. Once you start issuing certificates, if you decide to change the option around later, this may have an effect on your certificate hierarchy, and in the worst case, you may need to reissue certificates. When you reissue a certificate, this can have an effect on all certificate issues below it in the hierarchy. In the case of the root CA, reissuing its certificate will have an effect on all certificates issued in the hierarchy. I will now exit out of here, close all the open windows, and open Server Manager from the taskbar. To add Active Directory Certificate services, select Manage at the top of the screen, and select the option Add Roles and Features to launch the Add Roles and Features wizard. Once I am past the Welcome screen, the next screen will ask if the role being installed is on a single server or a remote desktop service installation. In this case, I am installing the role on the local server, so I will leave it on the default option and move on. On the next screen, I will need to select which server from the pool to install the role on. In this case, I am installing the role on the local server, and there are no other servers in the pool, so I can leave it on the default option and move on. On this screen, I need to select the roles that will be installed. In this case, I will select Active Directory Certificate Services. Notice that when I select the role, the wizard will prompt me to add an additional feature that is required for this role. This is needed, so I will press the Add Feature button and move on. The next screen will ask if I want to add any additional features. To install the Certificate Authority role, no more features are required, so I will move on. The next screen is the Welcome screen for the certificate role. This gives you additional information about Active Directory Certificate services. The important part to note is the part that tells you once you install the role, you will not be able to change the computer name, join a domain, or promote the server to a domain controller. If you want to do any of these things, you should do these first before installing the role. It is generally recommended that you do not install the Active Directory Certificate services on a domain controller. Once I move past this screen, the wizard will ask which components of the Active Directory Certificate service that I want to install. In later videos, I will go through the other components and how they work. For this video, I will only look at the first component, the Certification Authority. This is the core component, and this is required in order to use certificate services in Windows. Once I am past this screen, the next screen will confirm which roles and features are being installed. Once you are ready to perform the install, press the Install button. If you have installed roles in Windows Server 2008, you will notice that, unlike Windows Server 2008, the wizard does allow you to close the wizard and the install will continue. You will also notice that there were not as many questions as Windows Server 2008. These configuration questions have been separated from the role installing and must be done after the install. The install takes a minute or two to finish, but I have sped up the process so that we do not have to wait. Once complete, I will close the wizard. Notice on the left-hand side of Server Manager, there is now a section called ADCS. This will show information about the Active Directory Certificate Services role. Notice at the top of the screen is a message stating that more configuration is required. When I select the More option, this will bring up all the tasks that are required to be completed. In this case, one task is listed to configure Active Directory Certificate services. When I move my cursor over the action, this will show the action is to configure Active Directory Service certificates on the destination server, which I will select. This will start the wizard, which will inform the user currently logged in that they need to be a local administrator. Shown at the bottom, the user that is being used is the local administrator. Once I move past the Welcome screen, on the next screen I need to select which role that I want to configure. I have only installed the one role, so I will select it to configure the Certification Authority. Notice that when I tick this option, the left-hand side shows all the screens that are coming up in the wizard. If you have installed Active Directory Certificate services on Windows Server 2008, you will notice that these are the same options. Essentially, Windows Server 2012 has divided the install wizard into two parts, the install part and the configuration part. This makes it easier for Windows Server 2012 to install roles on remote servers. On the next screen, you can decide if the CA will be an enterprise or standalone CA. Note that the enterprise option is grayed out. This is because this option requires the server to be a member of the domain. In a later video, I will look at how to install a CA using the enterprise option. This option also gives access to some additional options that are not available to a standalone CA. In this case, I will leave it on standalone CA and move on. On the next screen, I need to decide if I want to add an additional subordinate CA or install the root CA. In this case, I will leave it on the default option of root CA and move on. On the next screen, you need to decide if you want to generate a new private key or use an existing one. If you had the private key in a certificate, this may occur because you have a backup on the key in a certificate, you could import the key here. In this case, I will leave it on the option to create a new private key and move on. On the next screen, you can choose what type of encryption you want to use for the private key. The first option, select a cryptographic service provider, allows you to select the algorithm that is used to create the certificate. The default choice is Microsoft Software Key Storage Provider. Any provider listed that has a hash in the name is referred to as a Cryptography Next Generation, or CNG. This means more features than the non-CNG providers, but also means less operating system support. CNG requires Windows Vista or Windows Server 2008 and above. This includes other CAs, for example, a subordinate CA. If you are using earlier operating systems for subordinate CAs or clients, you will need to select a different option. In this case, the default will work well for this network. The next option is the length of key. A larger key length will give you better security, but will increase the time taken to generate and check signatures on certificates. Also remember that if you are planning to use the certificates with hardware like VPN devices, these devices may have limits on how long the key length can be. 2048 has good software and hardware support, so I will leave it on this option and move on. The next option determines the hash algorithm that is used to sign certificates. The default is SHA-1. This, once again, comes down to what your client's certificates support. The option you choose here will determine which clients can use these certificates. I will leave it on the option SHA-1 as this has good software and hardware support. The tick box at the bottom, Allow Administrator Interaction when the private key is accessed by the CA, means that whenever the private key is accessed, Windows will prompt for an administrator password. In this case, since this server is the root CA and will not issue too many certificates, for security reasons, I will tick this box. If you have a very busy CA, you would most likely leave this option off, as each certificate that is generated would require an administrator to enter their password into the server. On a busy CA, this would be impractical. It is important to ensure that you are happy with the CSP, key size, and hash algorithm, as once you start issuing certificates, you cannot change your mind. In order to use different settings, you will need to create a new certificate hierarchy. I am happy with these settings, so I will press Next to move on. On the next screen, you will need to enter in a common name for this CA. This name will be used in every certificate that is issued from this certificate authority, so it is important to choose a good name. In this case, I will enter in ITFreeTraining root CA and move on. On the next screen, you need to enter in how long the certificate value is for. Since this is a root CA that will be secured and will be taken offline once it has issued the required certificates, I will enter in a value of 20 years. As you move down the hierarchy, you can reduce the value, but it is recommended to choose a high value for the root CA, since once this expires, effectively your whole certificate hierarchy expires with it. On the next screen, you need to decide where to store the data for the certificate files and the log files. It is a best practice to put these on a separate hard disk for performance reasons. However, since this is the root CA and will not issue that many certificates, I will leave them in the default locations since security and not performance on this server is considered to be important. The next screen is a summary of the options you have chosen. If you are happy with the options, press the Configure button and the Active Directory Certificate services will be configured. The configuration process only takes a few seconds to complete. Once complete, I will close the wizard and return back to the Server Manager. Now that the Active Directory Services has been installed, there is some final configuration that needs to be done in the registry before I can start using it to issue certificates. To do this, I will use the Certificate Utility command line utility called certutil. This needs to be done from the command prompt. To open a command prompt, I will press the Windows key and then press X. This will bring up a menu in which I can select Run and then enter in CMD to open a command prompt. The first command that I will run will set the fully qualified domain name that the CA belongs to. On an enterprise CA, this is set automatically since it is a member of the domain. In this case, this CA is a standalone CA that is not a member of the domain, and this value needs to be set manually. You can see the command here that is required to do this. All the commands that I will look at start with certutil followed by -setreg. There are a lot of these commands that are available, but in this case I only want to use certutil to set values in the registry that the certificate authority will use later on. The next parameter is ca/dsconfig.dn. All the following commands start with ca/ followed by the setting that needs to be configured. The next parameter indicates the fully qualified domain name. It is important that when you enter in the domain name, you use the correct syntax and also start with cn equals configuration. This domain name will be used in certificates that are issued using this CA. The next setting that I will set is the validity period units. This determines how long certificates that are issued from the certificate authority will be valid for. Since the root CA will only issue certificates to subordinate CAs, the period I use is 10 years. This is half the validity period of the root CA certificates. This command only configures the units, so the next value that I need to configure is validity period. This will be configured to years, meaning the validity period has been successfully configured for 10 years. The next setting I will configure is CRL period units. This determines how long a CRL, or certificate revocation list, is valid for. Like the last set of commands, 2 commands need to be run. The next command that I will run is CRL period, which I will configure for weeks. This means that a CRL will be valid for 52 weeks. It should be pointed out that these settings apply to certificates that are issued from this CA to subordinate CAs. When the root CA certificate was created, the CRL was set to 0 and thus disabled. The certificate the subordinate CA will use will have CRLs enabled, and thus it can use certificate revocation lists. This is what you want: the root CA not to use CRLs and the subordinate CAs to have the ability to do so. The next setting I will configure is CRL overlap period units. This will determine the time period that CRLs can overlap. When CRLs are updated, only the changes are sent. If you have a lot of changes happen at once, for example, a lot of employees are laid off, there can be a lot of changes between the original CRL and the number of changes that are sent through after the original CRL was created. If you have a lot of changes, it is best to use a low value. In this case, I will configure the value to 12, and then set the next value of CRL overlap period to hours. This means that every 12 hours, a new CRL base will be created. Every 12 hours, these changes will be discarded, and a new updated base CRL containing all changes will be created. The server is now configured. If you want to perform administration on the certificate authority, select the Tools pull-down and then select the option Certification Authority. This admin tool will allow you to view revoked, issued, pending, and failed certificates. In later videos, I will look at this tool in more detail. If you want to view the certificate containing the private key for this certificate authority, this needs to be done with the certificate snap-in. To access this, I will move to the bottom right-hand corner, open Charms, and select the search option. From the search box, enter in MMC and then select the MMC tile when it appears. Once launched, I will next select the option to add and remove snap-ins. From the list, I want to select certificates to view the certificates currently installed on this server. When prompted, I need to select the option Computer Account to view the certificates installed locally for this server and finish the wizard. I will now have a look at the certificate for the root CA. This can be found under Certificates, Personal, and Certificates. This is the certificate that forms the root of your certificate authority and thus needs to be protected. If I were to right-click and select All Tasks, Export, I can export the certificate to a file. You may remember that when I configured the certificate authority, I had the option to use a pre-existing certificate. This option will essentially read an exported certificate rather than creating a new certificate and thus a new private key. You would normally use this option when you recover a certificate authority. Once the export wizard opens, I will skip past the welcome screen. The next screen will ask if I want to export the private key. In this case, I want to select this option and make a backup of the certificate and the private key. It is important to remember that if you do this, this private key needs to be kept in a secure place. Once I move past this screen, on the next screen I will be asked which format I want to export the certificate in. In this case, there is only one export format that I can choose from. The option Include all certificates in the certification path if possible will export all available certificates in the hierarchy that this server can access. If the certificates cannot be accessed, the wizard will silently skip them. For this reason, even though it sounds like a way to back up your certificate hierarchy, it does not replace the need for backups. The next option, Delete the private key if the export is successful, will remove the private key from the server. Without the private key, the certificate authority will not be able to issue certificates. You would only ever consider using this option if you were removing the certificate authority role from the server. When exporting the certificate, ensure that the option Export All Extended Properties is ticked. This will ensure that all the data associated with the certificate is exported. Now that I have the options selected, I will move on to the next screen. On the next screen, I will tick the option Password and enter in a password. Since this server is not a member of the domain, I cannot select the options at the top. Since the private key is being exported, Windows requires a password to be put on the certificate to protect the private key. Once I have entered in a password, I can move on. On the next screen, I need to enter in a file name to save the certificate to. In this case, I will export the certificate to the desktop and move on. The last screen of the wizard will show the options that I have selected. Once I press Finished, the certificate will be exported. If you do export this certificate, it is important that you keep the certificate in a safe place. If I now exit out of here, the last thing that I want to look at is some details for the certificate. If I double-click on the certificate, you can see some information about the certificate that was created from the root CA. At the top, you can see the OID number that I put in the CA policy config file. At the bottom of the certificate, you can see who the certificate was issued to and also who the certificate was issued by. As you can see, these are both the same. This is what is referred to as a self-signed certificate. Normally, self-signed certificates are considered poor security and only used in testing environments. In this case, the root CA forms what is called the trust anchor of the certificate hierarchy, and it needs to be self-signed. There is no other way to do this. At the bottom you can see that this certificate contains the private key. Any certificate that contains the private key you need to protect. In the case of the root CA, if someone were to obtain this private key, the only way to get security back would be to regenerate the root CA certificate and reissue every certificate in the certificate hierarchy. The same applies to subordinate CAs. If the private key on a subordinate CA were to be compromised, that subordinate CA would need to have its certificate reissued, and any certificate that the subordinate CA has issued would also need to be reissued. If I press the button at the bottom, Issuer Statement, this will bring up the legal policy for this certificate. Notice the text information is in here that I entered in the CA policy file. If I were to press the button at the bottom, More Info, this will open a web browser to the location that I entered in the CA policy file. In this case, the server will not be able to access this page as it does not have a network connection. The web link can contain the policy for the certificate or other information of the certificate hierarchy. The advantage of having a web link is that the administrator can change the information, whereas the details entered in the certificate are not able to be changed after the certificate has been issued. Well, that covers it on installing a standalone root CA in your organization. Just the start of your certificate hierarchy. If you found this video useful, please consider subscribing to us to get the latest videos on certificates and other IT-related topics.